A little bit today. Last time I streamed, I was at a different desk with a different screen, different setup. Had that pretty well arranged. I want to make sure I get the same thing arranged at the desk that I'm usually at, so that when I have time to stream, like I do at the moment, that it's easy to just turn it on. So today, what I'm going to look at, for as long as I have patience, which may not be that much, is updating some things in package source. As usual, I have packages that I maintain that I like to stay on top of updates with. Variety of reasons for that, but mainly the way to manage the entropy of the universe is to try to track the entropy that you care about as eagerly as possible, instead of having it track you when it wants to. So there's a new version of this piece of software, Qsmtp, that I don't personally use, not because it's bad and not because it's useless, but because there are several packages in package stores for which this is true. I'm looking around for my magic wand to see if I can point some highlights at you. There I go. I need it on this screen. Hey, there you go. Okay, so hopefully that streams over to where you can watch it. Yeah, so this is a description of the software. It's called Qsmtp, and it's an individual project by one of the people that I collaborate with on not Qmail. So sometimes you'll see in the upper right of the stream that I'm working on Qmail, but today I'm working on package source to something that is adjacent to not Qmail. So Eike has this project, Qsmtp, that he's been doing for, I think, up a decade, maybe 2 decades, with replacements for part of the Qmail system, because this long predates the existence of not Qmail and the idea that there can be a maintained community project where we can change Qmail itself. This is the idea that because Qmail has this architecture that it has, the parts of it that you might want to replace, there's an interface that they conform to, and if you conform to the interface, then you can be replacements for them. So one of them is Qmail SMTPD, which is the part of the system that receives mail on port 25 from other email systems. And then there's a replacement for Qmail Remote, which is the part of Qmail that sends email to other systems on their port 25. And for a variety of reasons, the ones that are included in vanilla Qmail, and at this point still not Qmail, there are reasons you might want more functionality in them than is present. And so Eike wrote these replacements. And you can see some of the benefits of them. And there's a lot to like about it. And if I were in a different situation, I might be running them. I also, however, have written my own add-ons to Qmail, also predating the existence of a collaborative networking project on GitHub about updating the Qmail system. Now we have one, and so it's possible to have meaningful design discussions about what's the best way to get these bits of functionality integrated into the mainline system. My solution to some of these problems, not all of them, but some of them, is also a separate project, and it's also available from package source, of course, because everything that matters to me is available from package source. So this is Eike's project, the replacement for the 2 SMTP components. You might think that's the entirety of the mail server, the part that receives on port 25 and the part that sends on port 25, but there's a lot more to a mail server than that. This is kind of at the boundary, but the architecture has a lot more inside it. So he has a new version, and I want to update what's in package source to keep up with that. So let me try and do that. I'm on my Mac right now. Actually, I'm on a remote Mac. And this machine that I'm SSH'd into has the option of starting a bunch of virtual machines, which can be handy when we want to check whether some software builds on a variety of operating systems. We may want that. I often do. At least I tend to check at least a few before I commit so that users have to use what I committed. I usually check on a Mac because that's the native operating system that I'm usually closest to. I usually check on NetBSD because that's a first-class operating system also supported by package source. And then I usually check on some kind of Solaris or Illumos derivative. Triblix is one that I have run locally. And if I'm feeling generous, I'll check on at least one Linux. But there's a lot of Linuxes out there. I'm wondering if my levels are a little too high. Turn down the gain a little bit. Not blow your stack. Um, and just if it builds and installs on those platforms, then I can wait and find out other platforms that it might have a challenge with. Someday, I would like to have this kind of a build farm be something that every package source developer has access to, not just the package source developers who go to the trouble to install a whole bunch of virtual machines, but any package source developer, whether or not they have it locally. I would love for them to have this. And what I'd like to do also is have an easy way to submit a proposed change to the head of the package source tree and have it exercised, at least in the simplest case, to build the package itself, and maybe in more complex cases to do bulk builds of part or all of the dependency tree, which is 20,000 odd packages. So I would love to have that be automated more. There are ways people can get those builds done now, but it involves sort of manual collaboration. And I would love for this to be just infrastructure that package source developers have access to. So that's a project for another day. In the meantime, I have a lot of virtual machines, and that may be enough for us today. So the first thing we do to update a package is, I happen to know the new version is 0.39. And so in the simplest case, we just update the package metadata, which is stored in this make file. And we say make sum, which will fetch the tarball or whatever format it is with that new version. I happen to have fetched it already at some point. And it will update the checksums that are available locally. You'll notice I'm using CVS, but you'll also notice that my output looks a lot like a git diff. Happy to talk more about that anytime. I don't love CVS more than anybody else does, but it's what package source is currently using as the revision control of record. So you can see, here's the change that I made. I edited that into place, and then when I ran make sum, the infrastructure of package source took care of that. So there's a few different checksums. There's two. There's also a size. And we figured that's pretty hard to silently replace the contents of a distributed file and make the size match and two different kinds of cryptographic hashes match. So if all of these things match on a downloaded file, it is probably the same one that the package source developer fetched. And that's a way for, for reliability and safety in builds. So from here, again, in the simplest case, if there wasn't much changed here, then I should be able to say make package, and it will extract and patch and whoop. I think I had a build going already recently. Let's clean and go again. You can see all the steps. There we go. Now we're going from scratch. So this build uses CMake instead of GNU Auto Tools, or instead of, for a lot of things that I manage, DJB style configure checks that are also just part of the make file. And a lot of this builds, but a little of it doesn't. And it's hard to see exactly what just glancing at this. So one trick I like to do, it seems like you can see here it's saying there's another branch of a parallel make. Something I can do to help debug a make is to make it not parallel. I don't specifically suspect that there's a problem with the parallelism of the generated make file. CMake probably does that well. Um, but I do want to be able to see an error message as soon as there is one and not have to sift through. So for that, in package source parlance, you can say make jobs safe no, and then it won't try to parallelize, even if you have CPUs and you normally would parallelize. So this is going to build linearly, and as soon as it can't, it will stop. Okay. So again, this is on macOS 10. So we were able to build a few things. We were able to build a library for, I guess, understanding the structure of vpop mail, which is a virtual account system for, it's an add-on for Qmail, popular one. It did build the replacement SMTP server, and it did build the replacement SMTP client, and it built another tool that looks like it does some kind of a review of collected data, and it's trying to build test SPF, which isn't exactly part of the runtime service, but it might be something you would use to debug the runtime service to understand what's going on with SPF lookups. Sender policy framework is what that means. It's one of the ways that email has been retrofitted to try to validate who's sending and if they're sending from servers that they're supposed to be allowed to send from, which is a way to sometimes reduce the amount of spam that you get if the policy is sufficient. So this would be a useful thing to be able to debug why you might not be receiving certain mail or why somebody might not be receiving your mail. And it's not building, it's not linking is what it isn't doing. We were able to build the object of test SPF.c itself. We were able to build the needed objects spf.o and anti-spam.o, and then somehow the linking didn't succeed. Looking for something called SSL with an underscore in front, or maybe that's an artifact of the linker. Maybe it's SSL without an underscore in front. So let's see if we can figure this out quickly. Let's go into the extracted source and look for where test SPF is ever getting referred to. Yeah, so this is the place where it's getting built. What if we look at the top level makefile here? Does it say test SPF? Yeah, all very generated though. Okay, what's the next good place to look? It might be tools makefile. Again, a generated file by CMake. But this is what make will do when it's in there. This is the one. I'm not sure I understand what CMake is making here, but maybe we should go into tools, CMake files, test spf.dir. And that does not have an entire make file, but it has some things called .make. I gotta say, this one looks like a good name. I should look at that one. Not includes, this is very, very generated. Not sure I'm gonna learn anything looking in here. Okay, so working. Okay, these are a lot of dependencies that are declared. This might be a little bit helpful. Uh, let's look. So various things that tools slash test SPF need before you can build. How do I do it? Before you can build this, then you need to build this. And you can just add more lines and it appends dependencies. It de-append tendencies is what that is. So all of these are dependencies for building test SPF. Let's look and see if they look sensible. So this is the one that we saw here. And below it are the two that we saw below it. Then there's what looks to me like this file. In case it wasn't generated, will get regenerated. I guess that's more like it. And then there's these static libraries, which we see mentioned. We see one of them mentioned. Lib Qsmtp io lib.a has a read input function and a net and write function, both of which say SSL in them. And then nothing that we're linking with defines SSL. So I don't know why that is. I do know it would be a lot more suspicious if this wasn't here and this wasn't here, because that's where the SSL implementation comes from. It's from OpenSSL, and that Boolean would exist and be false if it wasn't linked with those. So it should exist and be true if it is going to be linked with those. And then this is just a bunch of library routines that I would also expect to be linked with. So I guess the place to look to understand what symbol this is, the linker is telling us the read input function that is part of this static library archive was defined in this object file, which based on CMake conventions means it's defined in this source file. So if I can find a source file called netio.c, then we could look at it for those functions that reference the symbol. So let's look for netio.c. There it is. And there's a function called read input. So the function itself doesn't have a underscore in front of it. That's something that the compiler or linker does when it puts it into this archive, or maybe when it puts it into that object file. But the name of the function itself is just read input. And I guess that also means that the net and write function is like so. And it also means that we probably shouldn't be looking for an underscore SSL. Probably be looking for a plain old SSL. So here's one of them. And actually, my editor is giving me some help there. Here's if SSL. So net and write writes one line to the network. And that how that works depends on if you are probably not whether you're compiled with SSL support, probably whether you're compiled with SSL support and the current connection is using SSL support. Trying to think how else that could be false. So where are we supposed to have gotten this symbol from? SSL timeout io.h. Suspect that's part of libofat. No, it's here. It's part of this tree. It's just okay. So do we think that this defines a symbol called SSL? No. Maybe this is supposed to? Mm, So that would come from build link, which I would think would be here. Where is that supposed to be defined? I imagine if you've worked with OpenSSL before, you would know something that I don't know. I'm trying to figure it out. So it was a guess that it would come from there. What about tls.h? Okay, yeah, this looks like something. So this is a pointer called SSL that is of type this SSL. An extern means that it's expected to be provided by some other object at link time. So which object could that be? Supposedly, yeah, so we're referring to it in here. By including this, the current compilation unit, this source file, is entitled to assume that there's something called SSL, and the type hint is that it's a pointer to a struct of type capital SSL. I assume that's an OpenSSL thing. That's why we're able to branch on it here because of that extern. So if we were to, what's the easiest way? If we were to go in here and comment that out, then I think we would not be entitled to do this here. I'm going to put that back the way it was. So we're looking for read input. Something is supposed to provide that name. Well, guessing again, but what about if we looked at the symbols that are defined on this one? Let's see if any of them are like that. No. And what about, yeah, are these all prefixed by underscores? It does seem so. So that's what the objects look like. And then what about libcrypto, the other OpenSSL library that we're linking with? This has a few symbols that aren't prefixed. It's mildly interesting. Don't know what any of this stuff means. Okay, and there's nothing there that's just called SSL. Let's take another tack, which let's look at the programs that did link, which I think also use SSL. That's kind of the point, and see if we can understand how they did it. So Qsmtpd. That would be in Qsmtpd, and look through these objects, like that one. Yeah. So for example, if you look at starttls.c.o, there's something in there. What's the U mean? Probably that it's not defined in this object. Let's look at starttls.c. Not exactly sure how to look for it in here. Maybe it's part of a branch again. Oof. Here's something. SSL equals my SSL. Yep. Okay, so let's look for that. Yep, that's an SSL object. And then if we can make one, somewhere down here, if we're able to do everything we want to it, then we define the symbol there. We're not returning it, so it must be some kind of a global. I think it's the same kind of a global. I think it's the same extern that we were trying to deal with in test SPF. So in this case, we've defined it after setting up an SSL object. Let's look at Q remote, start TLSR. I assume this follows a similar pattern. Yep, and we're setting it there and then returning 0. So again, this is the extern. These programs are providing them. So Qsmtpd defines its own SSL. Qremote defines its own SSL. Presumably test SPF is supposed to, or it's supposed to link with something that does. I'm wondering why the author missed this. I happen to know this compiles on NetBSD, links, and doesn't on macOS. Also links fine on Triblix, presumably on Linux because the developer primarily uses that. Excuse me. So then let's double check. I think it was tools, test SPF. So again, we are, is there an SSL happening in here? No, it's not part of this. Because this doesn't probably make a connection anywhere. Does it? Yeah, so it's just translating some information. Um, so then what is supposed to provide the definition of that symbol? Qsmtpd we saw like that. Qsurvey sets it to null. Maybe that's something for us to consider. Qenvelope test, netio test. Yeah, and these are coming from netio.c. So maybe we need to do something like either like netio test.c and just make a new SSL context, SSL object, or maybe we need to just initialize it to null so that it's initialized. Maybe that suffices. So let's try null. That's easy. Oh, test SPF. Yeah, maybe a little different, but let's try. I'm not sure this is the right compilation unit to define it in, but let's just give it a whirl. Sure, so let me include the file. What was it? Was that TLS? No. Yeah, include TLS.h. Okay. Let's just do it here. See if it makes a difference. So that should rebuild. No, okay. Now we got a new problem. Redefining SSL with a different type. Previous declaration was. That's the declaration I was hoping to have access to, you weirdo. Why didn't that work the way I wanted? Uh, is it because the include wasn't found? Because according to this file, we're calling it a pointer to SSL, which I don't know why we're redefining it with an int. Certainly didn't mean that. So can I just not do this? Should I be saying this? Do I need to include the OpenSSL include directly? Just smashing things together at this point. Yeah, then I have the type. Maybe that would work. Let's go again. Did not help at all. So the symbol needs to be in one of the objects. That is linked with. It doesn't have to be directly in this object. And the object file that needs it, or the function that needs it, is read input and net n write. Okay. I'm going to have to take a break shortly for a phone call, but I feel like we're on the right track, even though I haven't gotten this to change the way I want it yet. I see things that define this symbol, and somehow we need to define this symbol so that it can be branched on at runtime. So let's pause there and very quickly look at this on NetBSD. So over here, I can say, using my tool in progress, I can say package VM start NetBSD 9 AMD 64. It would be nice to have some shorthand for that, but it'll work. And then over here, I can say package VM shell. Once that's up, and we'll see that the new version of Qsmtp builds to completion and very nearly packages, and we can see what to do about that. And then we'll pause there. So here we are, my virtual machine is up. Go into mail Qsmtp and make package over here. Nearly done. So everything built and installed, and the only problem is package source is telling us there's a file that got installed that we weren't expecting to be installed. And the correct thing is that there's a new program, and we should expect it. So I'm going to add this to the packing list. I could do that manually by looking for where it goes alphabetically, but I won't. I'm going to say make print plist and have it regenerate the plist. And then we can see that that only changed what it should have changed. Yeah, and this gets regenerated on commit anyway, so it's fine that that changed. And now if we say make repackage, it will complete and succeed. And there we are. We have a binary package for this platform on NetBSD. So something about macOS and the way macOS links is sufficiently different from NetBSD and Illumos and presumably Linux, where the author does his primary development. So we got to figure out what's going on in macOS 10, and we will do that a different time. Thank you for watching, and see you next time.